In this section, we're going to start a big task or topic called finding antiderivatives. What does that mean? A function capital F is called an antiderivative of a function f on an interval I if capital F prime of x equals little f of x for all x in I. For example, let's find some antiderivatives of the function f of x equals x cubed. So we ask ourselves, what function would we have to differentiate to get x cubed? And probably the easiest one to see is 1/4 x to the fourth. Because if I differentiate 1/4 x to the fourth, I get 1/4 times 4x cubed, which is x cubed. So 1/4 x to the fourth is an antiderivative of x cubed. So we're going the other direction here. But notice that's not the only one. What if we looked at the function 1/4 x to the fourth plus 3? What would f prime of x in this case be? It would be 1/4 times 4x cubed plus, and then the derivative of 3 is 0, so again we get x cubed. So 1/4 x to the fourth plus 3 is yet another antiderivative of x cubed. So again, an antiderivative is a function that you would differentiate to get the original function. Let me point out one more. How about f of x equals 1/4 x to the fourth minus 5? Is that an antiderivative for x cubed? Let's see. If I differentiate this function, I get 1/4 times 4x cubed, and then the derivative of negative 5 is 0. So yeah, again, I get x cubed. And hopefully you can see that as long as I stick with adding or subtracting any constant to 1/4 x to the fourth, whether that constant is positive or negative, when I differentiate it, I'll get 1/4 times 4x cubed plus 0, so x cubed. So any function of the form 1/4 x to the fourth plus a constant is an antiderivative for x cubed. And I've gone ahead and given us a graph of a whole bunch of those. 1/4 x to the fourth, and then we have others that are, that's this one, and then we have others that have constants added to them, so they're shifted up, or constants subtracted from them, in other words, negative constants added to them, and so they're shifted down. But it's all the same function, just shifted up or down. That brings up the question, though, are there any other antiderivatives for x cubed? Are there maybe some sneaky ones out there that we don't know about, that if we differentiated them, we'd get x cubed? It turns out there are not, and that's given in a theorem that says if capital F is an antiderivative of a function little f on an interval I, then all antiderivatives of f can be expressed in the form capital F of x plus c, where c is a constant. So in other words, no, there aren't any others lurking out there. By the way, f of x plus c, capital F of x plus c, is called the general antiderivative of little f. So we just saw that if you start with a function little f and ask yourself, what function could I differentiate to get this little f? In other words, what all antiderivatives are there? we've seen there's really infinitely many because adding or subtracting a constant doesn't change the derivative once you differentiate. So this formula that gives the sort of the most basic antiderivative plus all the others by means of adding a constant, we call that the general antiderivative. So for example, let's find the general antiderivative of f of x equals 3x squared plus x. And then let's find a specific particular antiderivative whose y-intercept is 9.2. So to find the general antiderivative, we ask ourselves, first of all, we ask ourselves, what would one antiderivative be? What would like the easiest one to find be? So I'm going to ask myself, what would I differentiate, keeping it as simple as possible? What would I differentiate to get 3x squared plus x? Well, if I differentiated x cubed, I'd get a 3x squared. And then if I differentiated 1/2 x squared, I'd get an x. And then, as we just saw, if you tack on any constant, that doesn't change the fact that you have an antiderivative of the original function. Let's just check that we, in fact, have a general antiderivative. So if I differentiate the function, I should get back to the original function. So the derivative of capital F would be 3x squared plus 1/2 times 2x plus 0, and that is indeed 3x squared plus x. So what I have found is an antiderivative, and because of the plus c, it's the general antiderivative. It encompasses all possible antiderivatives of our original little f function. Now, for the particular antiderivative, whose y-intercept is 9.2, that would mean that f of 0 is 9.2, right? Because that's what a y-intercept is. It's when you plug in x equals 0. So for our general antiderivative, we have 0 cubed plus 1/2 times 0 squared plus c, and we want that to work out to be 9.2, which leads us to c equals 9.2. So the particular antiderivative is f of x equals x cubed plus 1/2 x squared plus 9.2. So any given function has infinitely many antiderivatives. If you express them in a single formula, that's called the general antiderivative. But then you might want to single out one particular antiderivative that has a specific property, such as its y-intercept being 9.2.